Okay, so second part of this polynomial functions. We're doing a graphing polynomials now through the example. Part A, write the polynomial p of x equals x to the power 4 plus 2x cubed minus 3x squared as a product of its factors. Now what does that mean, product? It's a times, isn't it? Times. And factors is something that x, something a, or x plus b, something like that. So we want something in the brackets, and in between is the times. Okay, so let's have a look. So p of x equals x to the power 4 plus 2x cubed minus 3x squared. Now common factor here is x squared, so I took it out and I left with x squared plus 2x minus 3. That's a quadratic equation. I can factorize it nicely because what's the factors of minus 3? That'll add up to 2. I can see this is a prime number, so it only have 1 and 3. And to have a positive sum here, I need to have bigger number to be positive, smaller to be negative. Okay, therefore my x roots or zeros will be 0, 1 and minus 3. Okay, now part B, sketch the graph of the polynomials. So let's push that up. So again, I've just done that previously here, but here again we can do x-intercept will be when y equals 0, x will be 0, 1, minus 3, like above that. We've done it already. Now, let's have a look at the characteristics of this polynomial function. The leading coefficient is 1, isn't it? Right? So obviously that's a positive. So it's going to be positive, and therefore the beginning and the ending direction of the graph will be the same, because what was the degree of this polynomial was 4, wasn't it? So degree was 4. So that means even power. Even power will finish and start and finish in the same direction. If it's a positive, it's up. If it's a negative, it'll be down. But here it's positive, so it's going to finish and start at the same direction. And also, let's have a look at the zeros, the roots. Now, when we look at equation, you can't probably see it. I'm going to just push it back a little bit. So we look at here, x squared. Now, when it's a quadratic in power of 2, it'll touch the x-axis. It'll touch. And when it's like linear function here, linear factor here, it'll cut through x-axis. So it's handy to memorize these characteristics of polynomial with the powers. Okay, so I can see when x equals 0, the graph will touch the x-axis, and then when x equals 1 and x equals minus 3, it'll cut through x-axis. So roughly, I've just got this first, I can see that it's going to finish and the start and finish at the same direction because it's a power of 4. It's an even function. And I know that minus 3 and 1 will cut through. But with a 0, I know that it'll touch, just touch, because it's a quadratic. Okay? So you think about quadratic as a parabola. So a parabola is it's a curved touching. So what I'm going to do, I'm just going to predict it'll go down here, and then it had to go up, touch, and then go up again. So it doesn't have to be accurate. So I'm just going to go through it, go touch it. So it's not as nicely smooth, but that'll do. Okay, something like this. let's have a look at another example. So let's see. So sketch the graph of the polynomial. So we got this, and p of x equals minus, so we got minus x squared, and then we have a factor x minus 3, x plus 1. They're all your zeros, yeah? So let's have a look. What's the first thing we need to do? It's x-intercept. We're finding a zeros, yeah? So zeros are x equals 0 here, x equals 3, x equals minus 1. So let's have a look at degree. So what was a degree on that? So x squared times x will be my degree, which is a power of 4. Again, this is even, so it's going to be all same direction to finish and start and finish. But this time it's a negative. So I'm going down. But it's still the same direction. Okay? And then let's have a look at leading coefficient. That's a same thing here. Because of a coefficient negative, and finishing and starting the same direction but downwards. Okay? And then let's have a look at the zeros. The characteristics of zeros here. So we got x squared here, which is x equals 0 here. So it'll be touching the x-axis, but x minus 3, x plus 1, which will give us the 0, x equals 3, x equals minus 1, will cut through x-axis. So let's have a look what's happening here. Okay, so I've done something already made up. So we know that and minus 1 and 3, it'll cut through. But at 0, it'll touch. So what I'm thinking is you go through here, going down a bit, and touch it, going up again, and going down again. So that's what I'm planning to do. Hopefully I can sort of sketch a little bit nice, smooth, because don't forget it's a curve, so you need to sketch it a bit. Again, it doesn't have to be accurate, but need to have a same, like, correct shape, where it's gonna start, where it's gonna end, where it's cut through, where it's actually touching. So you need to think about that. Okay, all right, next one. Let's have a look at this one. This is sketch p of x equals, now it's a cubic, because your degree, when you times all these, you'll get 3. Now, also, what is it? This coefficient, leading coefficient will be 1, which is bigger than 0. Now, when it's a cubic and it's a positive coefficient, you will expect something it's going up. Yeah, something is going up. When it's negative, it'll go other way, going down. Yeah, so this is what we are expecting. And let's have a look. I'm going to push this up. So we got zeros will be 3, 2, minus 2. So I've got 3, 2, minus 2. They're all cut through, okay, because none of them is quadratic. So it doesn't touch. It actually all cut through because they're linear. So, but it needs to be, start from down and going up, finishing up. So I just already put there. It's always handy to actually give some directions before you can start, so you can actually predict what kind of curve sketch you're gonna have to do. So I'm gonna go through here and then come up and go down, because I have to go through it, cut it, and then go up. So that's what I'm gonna do right now. So that's what I've done, and it's not vertex of, it's just going through it. So I probably could have done a little bit better job here. But anyway, so that's my y-intercept when x equals 0. So I need to, it's good to actually get all the x-intercept, y-intercept, and the x-axis and y-axis and origin on in your graph. So I'm gonna do this maybe on here, maybe that. Okay, when x equals 0, what will be my y value? Okay, so that I can put that in there. So it'll be 0 minus 3, 0 minus 2, 0 plus 2 equals minus 3 times minus 2 times 2. That will give me 12. So here is my 12 here. And that's my graph for a polynomial function.